Welcome back. So continuing right along, let's look at some more things that we can do with queries using SQL. So next let's talk about some calculated fields. So I'll bring this up here. I will create a new query. Switch to SQL view. Good. So let's look at our employees table. So throw that in there. Employees, great. And then I'm going to select first name, last name, and then we'll select title. So before, actually, I'll come back to that. I'll keep title in there for now. And then I'll select salary. So we're talking about calculated fields. And so what that is performing calculations on data that already exists within the table. So in this case, we're going to look at the salary field, and so the data that's in this field is a monthly salary for the employee. So what we're going to do is we're going to calculate out that salary annually. So the asterisk is going to be used to symbolize multiplication. So all we're going to do is simply multiply that by 12, and then we can specify a where clause. We don't need to, but let's do it anyway. We'll say where title is equal to network specialist. Alright, so let's run this. Good. So we have our first name, our last name, our title, and then this really weird named field. But it did our calculation correctly. Salary times 12 gave us that, right? We can verify by just simply removing it. 7,000. 7,000 times 12, 84. Good. It goes back to its original field name, so that's nice. But when you do a calculation like this, when you kind of manipulate a field, it kind of auto-generates a field, a column name for you. Most of the times you probably don't want that. So what you can do is you can use the keyword as, and then you can give it any name that you want. So we'll say something like yearly salary. And now that will take on that name for that column. So the keyword as, you can also refer to it as like an alias. So that doesn't just apply to calculated fields like this. We can do it to essentially any field. I could say title as job, right? And then run this, and then we can see that the name of the column changed from title to job. So it's just an alias, just a way to change the name. It doesn't change it in the actual table. Remember, queries just kind of retrieve information and display it separately. It doesn't actually generate the data or anything like that. All the field names in the table are still their original names. They haven't changed. So, which is nice because that allows us to create multiple queries where we can, give them different names if we need to, or different calculations and things like that. So we can do that. We can also calculate fields. This isn't really calculating fields, but we can concatenate text, meaning that we can push it together, right? So typically in databases, you're going to have separate fields for names, for first and last name, just because it's easier to keep track that way and filter out the data when you need to and search for it and things like that. But maybe sometimes in your results, you're going to want to just see the names together because it's going to be easier. So you can concatenate them, which it just means to put text together. And you can do that with the ampersand. And so we're going to say that, and then another ampersand, just like that. And so the reason why we're doing this, right, is because all we're doing is we're saying concatenate this with this text and then concatenate that with that text. And the reason that we're doing that is we're just adding in a space so that there's a space between the first name and last name. So, you know, for instance, if I just took this out here and ran it, so there we can see the names are kind of smushed together. Again, we get that randomly generated column name. So it doesn't look very neat, doesn't look very clean. So we'll add that back in. That was in the wrong place. We'll add that back in. And then we'll give it an alias. So we'll say full name. So perfect, that looks much better, right? So you can get, you know, very specific and very detailed in your queries. You can really do a lot with your queries. It's really kind of cool. So we can also do other calculations, addition, subtraction, division, you know, all the basic arithmetic. So I'll give you an example of that. I'll also show you this, which is really kind of cool, right? So we have this calculated salary field. We gave it an alias, and so we can use this new calculated field by its alias. And so what I mean by that is now let's select that calculated field that I just created, and then you know, I'll just say plus 10,000, and then we'll call this field salary with a bonus, right? So we'll say it's their yearly annual salary with a $10,000 bonus. So we run that, we got our calculated field, the yearly salary, and then we have this new field that uses this calculated field that we kind of created, and then we did more calculations on that and gave it another alias. So that's really kind of neat. All right, so yeah, calculated fields, easy peasy, fresh and squeezy. All right, next let's talk about using wildcards and the like operator. And so I've showed you the asterisk before when we're selecting columns and how we can use that to select all columns. But what it really essentially is saying is that any value can match, right? Which is kind of a weird way of thinking about it. But when we use it for our criterion, I think it's going to make a little more sense. So let's kind of take a look at this. So I'm going to create a new query here. And I'm going to use our project line items table. And so from this one, I'm going to select, these have long names, huh? Let's say I'm going to select project ID and task ID. Task ID, and then I want the project line item notes. Really long name. Project line item notes. That name's too long, so I'm going to change it. I'm just going to say notes. Select that from that, and then our where clause. So we're going to use my alias here, and I'm going to say where in the column notes, which is really project line item notes, keyword like And then because this is a text field, I'm going to specify that. And I'm going to say asterisk difficult asterisk quote. So I'm going to select these three columns from the table project line items. I'm going to rename this column to make it easier. And then I'm going to say where all of the records within this column are like this condition. And so this condition, what it means is I'm looking for the word difficult, but I'm saying that there can be anything before or after it, right? If I do not have those asterisks, it's going to look for just that one word. And so the description of the project line item notes probably doesn't have just that one word in it, but it probably has that word with other notes attached to it. So now I'm going to say that there can be anything before it and anything after it. So let's run this and see what it looks like. So this actually brings up a good point. So I'm essentially kind of getting an error here. And that's because aliases are great, but there are only certain clauses that you can use them in. And so you can use them in a clause that we haven't gone over yet, which is order by, but we can't use them in where or group by or another clause called having. So that's why that's kind of throwing an error there. So yeah, just kind of something to keep in mind. But if I just replace this with the original name, then it should run. Yep. So there, again, the whole point of this was we're using the asterisk around the word difficult, so we can say that anything can come before difficult and anything can come after difficult. And so, we can see we have different text on both sides of it in both cases. So that's pretty great. And so to just kind of demonstrate the validity of it, if I were to take away these asterisks now and run it, I'm going to get nothing, right? And that's because it's looking for only just this one word in that entire column. But if we look at the column, it's a place for notes. So there's statements and things like that. And so if we want to just look for that one particular word, then that's why we encase it in asterisks. So that returns nothing. Asterisks on either side means that we can, say that anything can come before or anything can come after it. So, another example, and I'm not going to do this, but another example would be like if you had a database of all the phone numbers in the country, in the USA, right? But you only wanted to search for phone numbers just in New Hampshire, right? You could specify and then you could say 603 asterisk. And so now you're going to say that it's going to start with 603 and anything can come after it. And so, conversely, you can do it the other way around too. Asterisk there, and then you can say, anything can come before it, but it's going to end in 603. So that asterisk is that wild card. It's essentially saying any value can match. So that's cool. This next condition is using the in operator. So you can see an example right there. I won't retype it. That wouldn't make sense. But we can see what's going on here. We're going to select all the columns from the employees table. And what the in operator is saying, it's saying that we're going to match any of these arguments that we provide. So we're going to look in the title field, and I want you to return all the records that one of these match. So you can kind of think of it as the same way as in the where clause, typing where title is equal to database developer, or title is equal to front-end developer, or title is equal to programmer, right? It's just kind of a more concise way of doing that. But as long as one of those entries matches a record, it's going to return those records. So when you run it, you're going to get all the records of all the database developers, all the front-end developers, and all of the programmers. So now let's look at sorting our results. So sometimes when you run a query, you may get a very large amount of results back, and you may want those records sorted in a specific way. And so that's very easy to do. So come up here. Let me close all these. I don't need to save these queries. All right, so I'll create a new query here. Switch to my SQL view. For this example, I'll use the employees table. So I'm going to select last name, first name, and title from employees. And then to sort our records, we're going to use the clause order by. So whichever column that you select order by is going to sort by default in ascending order. So let's do it by title first and take a look at this. And good, so there we can see all of our records have now been sorted alphabetically by title, by their job description. So that's pretty great. But in a case like this where we have multiple of the same title, right, or multiple of the same field, multiple copies of the same value in this field, we may want to sort on another field as well. So easy enough to do. All we do is just say comma and then the next field that we want to sort on. And so the order that you list out in the sort in the order by is going to take precedent, meaning that title is going to be sorted first and then last name will be sorted after that, and then if you have any after that, then so on and so forth. If I swapped these, it would first be sorted alphabetically by last name and then by title. So now I can run this, and now it's still sorted alphabetically by title, but now last name is also sorted alphabetically. So that's pretty great. And so again, by default, it sorts by ascending order, but we can change that if we want. We can just simply say, descending, and then run this. And now, our titles are now sorted in reverse order. So that could be helpful as well. So next up, we have our aggregate functions. Again, this is looking at all of the records collectively, and we looked at this when we were using our QBE query by example. And these are the built-in functions that we looked at, sum and average, count, max, min, all of those. So let's kind of take a look at them in action in SQL. So get rid of these. We don't need order. So we're going to use the employees table. I guess I could have left that one up there. And so what we're going to do for this example is we're going to look at how many total employees we have and how much they make collectively. So to look at how much they make collectively, well, let's first do the number of employees. So the aggregate function for that is going to be count. And then we're going to specify And so, we would specify a column name like employee ID. Whoops. And then because we're doing a calculation here, a calculated field, we're going to give it an alias. So we're going to say number of employees. Number of employees. Good. So I run this and we see that we have 28 employees. So what this is doing is it's going through the employees table, looking at the employee ID field, and it's counting how many records are entered into that field within that table. So essentially it's just counting the number of records in that table, which is going to tell us how many number of employees there are. So with this particular example, we don't really need to specify a specific column. And so what I mean by that is we could just say that because it's still going to count every single record that's in there. So I get the same result either way. So whichever way you want to do it. And then, so that's our number of employees. So now let's look at their total salary. So because we want to add up the salary of all of our employees, we're going to use the sum function. And we're going to use this on the salary field. So remember, sum is a aggregate function that can only be used on a numeric field that has a number for data. So we'll add up that and then we'll set that as total salary. So again, we're looking at all the records in the table. Count is going to tell us the number of records that there are, and sum is going to add up all the records together. So that's the big difference between count and sum. So we run this and we get 28 employees that make a total of $162,950 altogether. So that's pretty great. All right, so the last thing that we'll talk about in this segment is grouping our records. And so we saw that in some of our tables, some of the fields have the same value in a particular field, much like, in the title field in the employees table, we have several people that have the same title, the same job, programmer, network specialist, things like that. And so what we're able to do is group those records together, and then if we need to, we can do some aggregate functions on that group or whatever we're trying to do. So let's take a look at an example of this. So we'll use that example that I was just talking about, right? So we're going to say select title, and so let's design a query where we're going to return all of the titles and how many people are in each title, how many people have each job, and then we'll group them together by those job roles, by those titles, and then sort them by the number of people that have those roles. So we're going to do title, and we're going to do the count function to get the number of people inside those titles. And then we'll say number of title. This is and then we'll say group by, and we're going to group it by the title, right? So it's going to put everybody that's a programmer into one group and everybody that's a network specialist into another group, right? And then we're going to get the count of each record in that group. And then we're going to sort them. So we're going to say order by, and then we want to sort them by the number of those positions. So we'll say count again. Whoops. Asterisk, good. And then let's sort it by the positions that have the most employees in that role. So in that particular case, we're going to want it in descending order. And then, of course, the name of the title. All right, so let's run this and take a look. Good. So here's each role, each title. So every record in the employees database has been grouped by their title. So all the programmers were put together, all the database developers were put together, and then we ran the aggregate function of count on each record so that we're counting each record in each group, right? Because we grouped them together and we ran that count. And then we are ordering them, we're sorting them by that count. But because I put in descending order, it's going to put the largest numbers up first. So it's going to tell us which group of people, which title has the most employees in there. So that's pretty awesome. So that's using our group by. So now let's talk about the having clause. And so the having clause is basically identical to the where clause, whereas the where is referring to specific individual records, and having clause is used for groups. So looking at this same example, what I can essentially do is, after I've grouped them, I can say having, and then again, this is like very similar to the where clause where you're going to specify some criterion. So let's say we'll look at our count again. We'll say our count, and then we're going to say for any count that's over 4, right? So this is going to group all of our employees by their title. It's going to get a count of each group, and then because we're adding in this having, we're only going to display the groups that have a count greater than 4. And then of course we're going to still order it the same way. Good. So that only returns 2 groups, the programmers and the front-end developers, both of which have a count over 5. So again, the having clause, basically the same thing as a where clause, but only it refers to a group of records. So to compound things even more, we can use both having and the where clause. And so the where clause will always come first, because that's kind of going to filter out individual records before we start to group them together, right? So for instance, let me just change this to 2 so that we can at least get a little more results. All right, so we got 4 groups there, that's fine. So I'm going to add in my where clause here, because again, the where clause needs to happen before the grouping and the having, because where refers to the individual records. So we're going to filter our results, filter out those individual records first, and then we can group the remaining results, and then we can, filter out the groups and so on and so forth. So let's say where title, I'm going to pick on the programmers here again. I'm going to say not title is equal to programmer. So we're just going to get rid of our programmers again. I really have nothing against programmers. I actually really enjoy programming, but my main specialty is networking, so that's why I got to pick on them. So let's run this, and good. Now my 4 records are down to 3 because I've used that where clause to eliminate any record that has a title of programmer. So starting to get really complex query statements here now, really complex SQL statements. So select from where, your 3 like basic clauses that you're almost always going to have, and then you can group results together. You can filter those groups using the have clause, and then you can order the results with or without a group using the order by, sorting all of the results. So that's a lot of really good, a lot of really useful information, but it is a lot of information. So I hope it sinks in. Rewatch this video again if you need to. If you need more help on this, please come to me and let me know. We are starting to get into a little more complex topics, but it's really good stuff, really cool stuff that we can do. So I hope you guys have found this useful, and we'll see you in the next segment.